Hi all. Today we will discuss the module 3 of signals and systems. In the last module we have discussed about the Laplace transform, its properties and transfer function, etc. And in this module we are going to discuss Fourier series and Fourier transform. The first part consists of the Fourier representation of continuous time signals, Fourier series, and harmonic analysis of common signals. And the second part consists of Fourier transform, existence, properties of Fourier transform, energy spectral density and power spectral density, and frequency response of LTI systems. The Fourier series was first introduced by Joseph Fourier. He was studying the mathematical theory of heat conduction, and he established the partial differential equation governing heat diffusion and solved it by using infinite series of trigonometric functions, sines and cosines. So this Fourier series and Fourier transform is used for variety of applications. The Fourier series. Any periodic waveform x of t could be broken into an infinite series of simple sinusoids, which, when added together, would construct the exact form of the original waveform. So, we are breaking up any periodic signal in terms of simple sinusoids. Now, what is the difference between Fourier series and Fourier transform? The Fourier series is used to represent any periodic signal, whereas Fourier transform is used to represent non-periodic signals. As we have already mentioned, the Fourier series is an accurate representation of a periodic signal and consists of the sum of sinusoids at the fundamental and harmonic frequencies. The waveform x of t depends on the amplitude and phase of every harmonic components, and we can generate any non-sinusoidal waveform by appropriate combination of sinusoidal functions. Now, we have discussed periodic functions and non-periodic functions in module 1 in detail. So we can recap it. X of t equal to x of t plus nt where t is the period of the function. So these are the few examples of periodic functions where it satisfies the property x of t equal to x of t plus nt. Now we will see the equation for Fourier series. In our BTech days, we used to tell the Fourier series as Fourier series because it will take 4 years to solve one problem in Fourier series. You might have also experienced while studying Fourier series in calculus, in mathematics. Anyway, we will see the equation x of t equal to a0 plus sigma n equal to 1 to infinity an cos n omega 0 t plus sigma n equal to 1 to infinity bn sin n omega 0 t, where omega 0 equal to 2 pi by t. T is the period of the function, and a0, an and bn are real and are called Fourier trigonometric coefficients. Now we will see the expressions for Fourier trigonometric coefficients. A0 equal to 1 by t integral t0 to t0 plus t x of t dt. So that is nothing but the average value over one period. So the integration is for one period. An will be 2 by t integral x of t cos n omega 0 t dt, and Bn is 2 by t integral x of t sin n omega 0 t dt. So these are the equations for finding out those values, and Fourier series exists only if following Dirichlet's conditions are satisfied. The first condition is x of t is well defined and single valued function, and the second is x of t must possess only a finite number of discontinuities within the period t. And the next point is x of t must have a finite number of positive and negative maxima in the period t, And the last condition, the integral x of t dt is finite. Now, we will see the Fourier coefficients of signals with symmetry. We have discussed in detail about the even and odd signals in first module. So, we can recap it, that is x of minus t equal to x of t is even signal and x of minus t equal to minus x of t is odd signals. And here Bn will be 0 for even signals, whereas A0 and An will be 0 for odd signals. So there is no need to calculate Bn's for even signal and A0 and An for odd signals. In some cases for even signal, A0 will be also 0. The average value may also be 0. For some cases it may not be 0. Now we can discuss one example. Find the Fourier series of the following periodic functions. So we can see the wave. Now what is the time period t of this wave? So that is repeating. So the t is, the time period is 4 in this case. And let us choose one period. So we have to integrate the for one period. So let us choose from t equal to minus 1 to t equal to 3. Now what is the fundamental frequency? That is omega 0 equal to 2 pi by t. So 2 pi by 4, that is equal to pi by 2. So our aim is to find out x of t. And we are defining it x of t equal to 1 for minus 1 to 1 and minus 1 for 1 to 3. So we can split the integration. So we have selected the period from minus 1 to 3. So we are splitting it into 2, minus 1 to 1 and 1 to 3. And the value is 1 for the interval minus 1 to 1 and minus 1 for the interval 1 to 3. So first we can calculate A0, 1 by t integral x of t dt. So t is 4, so 1 by 4 integral minus 1 to 3 xt dt. So we will be getting A0 as 0. The average value for this function is 0. And the next thing we have to calculate is An. An is 2 by t integral xt cos n omega 0 t dt. So we are integrating from minus 1 to 3 and splitting the integration minus 1 to 1 and minus 1 to 3 and giving the values of x of t. Minus 1 to 1 the value is 1 and 1 to 3 the value is minus 1. So integrating and applying the limits minus 1 to 1 and 1 to 3, the integral of cos will be sine and then we are substituting the values 1 and minus 1 limits, applying the limits 3 and 1 and the final we will be getting 4 by n pi sine n pi by 2. So this is the value of An. So we have got A0 equal to 0 and An equal to 4 by n pi sine n pi by 2. So substituting for n even, the value will be 0 because sine n pi by 2 will become 0. And for n equal to 1, 5, 9, 13 etc. it will be 4 by n pi. Whereas n equal to 3, 7, 11, 15 etc. the value will be minus 4 by n pi because sine n pi by 2 will be 1 for the first case and it will be minus 1 for the next case. And here this signal we have done as even signal, x of minus t equal to x of t. Therefore, all the bn's will be 0, so no need to calculate. Even if you are going to calculate, you will get the result as bn equal to 0. So we have got A0 equal to 0 and we have got the expression for An and Bn's are 0 and the equation will be reducing to only this term, sigma n equal to 1 to infinity An cos n pi by 2t. and substitute 1, 2, 3, etc. So first term we will be getting an 4 by pi cos pi by 2t, and the second term, so that's how we are getting the all series. So we will